Hello, I think we're live now, and hopefully you should all be able to hear me just fine. Live now. Yeah, and hopefully you should all be able. I think volume-wise everything sounds good. You guys can hear my voice, you guys can hear the songs, and welcome to another stream. It's good to see people again. I'm not sure if there's anyone quite yet just watching, but welcome. Today we're going to be doing the 1 billion challenge in C++, and I've got some ideas already on how we can kind of optimize this thing. Hello Robin, it's very nice to see you, sir, and welcome to another stream, man. Hope you've been doing really well. Right, so I actually want to get this done today, so let's actually begin looking at the problem at hand. So I'm guessing that most of you have already seen this problem, and in fact it's one of those things that was suggested by one of the guys on Discord. I think Slim was the one who suggested it, and I was down to do it. So today I wanted to do something a little bit more light, something that isn't gonna well, there's not any of my projects really, so a little bit more fun. Rough times. Have math exam tomorrow, been studying all week like a maniac. Dude, yeah, I mean, I appreciate that you're here, Robin. I appreciate the likes that you're probably going to drop on the video, so thank you very much. But yeah, man, take your time and go study. Exams are more important than chilling out with me, so make sure you ace that. But yeah, dude, I wish you the best of luck though. Saying that, there's nothing wrong if you just want to keep me on the background. I appreciate that too, but if you need to focus, man, you need to focus. Go do your exam. Yeah, looking at the problem. So the problem here on the 1 billion challenge is that you have a text file. Actually, it's supposed to be a CSV, but I'm not sure if it's a fully fledged CSV, and it has 1 billion lines in it. Each line has the name of a city in the world, and then it's followed by a temperature, which is an integer. So it could be something like minus 23.5 or plus 5.7, something like that, right? And I did actually create a very sort of dummy test here. Let me see if I can find it, with actually 1 billion lines in it, because they don't actually provide it on the challenge page as far as I can tell. They provide a little kind of test file, but that only has like 100,000 lines in it. So this file has actually got a billion lines of measurements, and you can see all of them here. And in addition, it's got 175 megabytes of data. So that's what we're dealing with here. Yeah, but we can only do so much math in one day. Way over the limit. Yeah, dude, I understand. I remember my days as well. I mean, fun fact, on the last maths exam that I had, I studied straight up for like 2 days, like non-stop, because it was actually one of the last exams I had anyway. So it was like one of the 2 last exams I had. And I just couldn't sleep because I had that mentality that university is going to finish soon, and I was really excited for it. But at the same time, I wondered, like, I didn't wonder, I was genuinely worried that if I didn't revise enough, I wouldn't do as well at uni. So I just didn't go to sleep. I went to sleep, maybe, I lie, I kind of got 2 hours of sleep on that day. But I revised for it until like 4 AM, and I woke up at 6 to kind of revise more for my exam before the actual exam at 9 AM. So that was my life. But that's gonna be over soon, my dude. So as long as you do well, you know, you're gonna be fine. So this is the million line text file. Sorry, the billion line text file. And you can kind of see what it looks like. It's fine, right? There's a billion lines of text in it. But you can also see that some of the characters here are not ASCII characters, so I guess we do have to handle the cases where we don't have an ASCII character. But yeah, this is what we have to do. Basically, we have to read this entire file and then calculate the minimum, maximum, and average temperatures for each city that's mentioned in this file here. So a very naive approach, I guess, would basically to, I guess, read all of the files, and then for each line we're going to put we're going to create a new entry on the map if it doesn't already exist. So for example, Tokyo here, it's going to be a new entry, and each entry is going to have a min, max, and average, and we're going to do a rolling average sum on all the values, and then we're gonna just update the min and maximum values if we need to, right? That's the very naive approach, and yeah, let's go with that, right? So first thing to note here is that the file is very big. It's for a text file, it's kind of quite large. It's 175 megabytes of memory of disk space, but it's not too large. In fact, we can actually load the entire contents of the file in memory, actually decompressed, and it's only going to be less than 200 megabytes, right? So we're going to use that approach first. We're going to actually try and read the entire contents, and to do that, we're not quite going to read line by line. We're actually going to use a memory mapping library, actually a portable one called MIO, Memory IO. And what this does is it just maps the file into the memory of your machine, right? So if you have 200 megabytes free in your machine, it's just going to take that file in memory and then say, you know, it's part of the program now. So we're not actually reading any buffers. We're not making any like syscalls to read buffers and stuff like that. We're simply just mapping the file, and this works very well for when you are kind of loading large files that you don't necessarily want to change, and you might want to read into it multiple times, which is what we're going to do, by the way. We're going to read into the file multiple times. In fact, we might even have like multi-threading on this to read only part of the file in each thread, and we're going to kind of merge all the results later on. That's my way of thinking right now. Arkanaf, hey, my day suddenly got much better. Thank you. My day got much better as well, Arkanaf, now that you're here, dude. Welcome to the stream, man, and I hope you're doing very well. So yeah, as a head start, I actually have a little project here that I actually created for a blog post. So if you guys have checked out my blog, my blog, do check it out. I mean, it's not very up to date, because I think the last post I did was actually this one, which is maybe like 5 months ago. Can't remember. But I explained how to create a thread pool, and we're going to use this project as a startup, because we are going to probably use thread pools here to read or to calculate parts of the analysis for the file, right? So my machine, for example, has way more than, I think it has actually got 6 true cores. So at the very least, we can do 6 threads that are each going to read an individual part of the file, right? So that's what we're going to do here. So I guess that we're gonna probably need thread queues, as I said, meaning that it's just easier if I start from the project, which has a thread pool already implemented here in C++ that I actually implemented myself. So if you guys are interested in that, I can post a link in here. If not, don't worry about it. The only thing that I don't quite yet have is the ability to load in third-party packages, right? So I want to load MIO, which is as I mentioned, is a memory mapping library. So let's do that. And what I'm actually going to do is just copy a Conan file. Again, I'm going to work with Conan here. Hopefully this time we're not going to have to to fix any recipes, because this library is actually quite small, and I'd be very surprised if Conan doesn't just build for that one. But you know, it's Conan, so it could happen. It could happen. So let's copy it from the base64pp and Conan file into here. Now we have a Conan file. Let's also copy. What did we do last? I can't remember now. So it's the 65K. Let's copy the CMake presets from another project into here. So now we have basically got some presets for including Conan in here as well, right? So that's what we're doing. Maybe it will be worth it for us to actually include other libraries, such as, I guess, the Google benchmark, right? So let's open another instance here of the Conan recipe, and then let's look at Google Bench, I think it's called. So benchmark. I'm interested now. Should we use a different benchmark? I'm finally starting to understand Qt, and I will soon have a C++ project that's finished. Then you could do a code review on that. Yes, please, Robin. I want more of that, dude. I want to do some more code reviews here on stream. I've made it. I made this point before, but I don't really get that many viewers who actually have a lot of finished projects, because interestingly enough, I think like 80 or 90% of you guys are quite new to the industry. I think most of you are actually students, like yourself, Robin. So it's difficult to find people with like full-on projects that I can go and review and give my opinions on them. But yeah. Google used to have a benchmark. It's just called benchmark, right? Yeah, it's just called benchmark. So this is the one, I guess. Yeah. So I've used this library before. It's kind of useful to have it lying around, just so we can like perhaps compare one implementation to another implementation here quite easily. So we're gonna do this, and as I said, MIO is another one as well. And we'll leave Google Test here for now. Yeah, we're gonna reload the window because now we have Conan settings. I mean, I have a lot of TypeScript and web related projects, but I'm not super interested to look at. C++ is much more fun. You're surprised you find that, dude. A lot of people see C++ and want to go straight back to JavaScript and TypeScript. Unfortunately for me, I don't really have a much of a knowledge in TypeScript, so I never really got the gist of it. I mean, I never really did a lot of like web development, so yeah, never really had to learn it. But anyway, we got CMake here, and let's do a Conan install, shall we? With Clang 17. We're going to be working from the latest and greatest versions of C++ and the compiler, so we've got Clang 17 here. And it's worth noting as well that if we do get a solution today, I'll be very happy if we get a solution, not necessarily the most performant one. But if we get a solution, it's worth noting that we're running this on WSL, which means the results are going to be a bit skewed. So if it takes overall something like 10 seconds to run, actually, if you build it on actual hardware, so on a non-WSL version of Windows, non-WSL version of Linux, or even on Windows, it might be a lot faster, right? So that's one of the things we can take into account here. Always enjoyed the more low-level and old-school methods. Always found them way more interesting than the modern things. I agree with that, dude. I always found that the case as well for me. Like I understand the need for higher level languages, but I like to sometimes get down to the hardware, right, and be able to write some code for a microcontroller or something like that, where I kind of understand what's going on. But yeah, so we've got everything, and we kind of can select the configured preset, and let's do that. So CMake, we need Unix Ninja Clang debug, right case. So you have the debugger here, and I think we're ready to start, right? So we've got the thread pool, and we've got the thread pool safe queue here. I would love to see if my test application still runs. So we have a test application in here called Unix Debug Ninja, and I want to see if this still works, right? So let's run them. Oh yeah, we haven't actually built a thing, so. Okay, so it has exited with 1 here. So, oh, look at it! Look at what it is. We have a memory leak somewhere. Do we care about this well enough right now, though? I am interested to figure out. I'm kind of debating whether or not I should actually fix this. This is code from quite a while ago, and I'm not too sure if I should worry about this too much. I mean, as long as it completes, right? But yeah, I mean, let's take a look. I mean, it could be helpful. So we have a lock guard on IO stream lock guard here, and we only. So this test program is doing a couple of things actually, from what I remember. So I have all these types in the thread pool namespace, which basically implements a thread pool, and then obviously thread pool is a class itself, and it takes a few kind of structures in it. So like within a thread pool, let's see if we can see it here. So you can create a thread pool with 4 cores, so 4 workers in fact. This is what it means. And then we kind of push tasks into it, right? So in here, I believe I'm pushing 100 different tasks. So all these tasks are stored in a queue, in a task queue, and then we pop each task one by one. So we we run the start of the queue, and yeah, we assign them to like each worker. So worker 1 gets task number 1, worker 2 gets task number 2, and so on and so forth. And then as they complete, they get new tasks assigned to them. When you grow up in a small rural village, you crave the luxuries of the city life, like hot water, natural gas infrastructure, fast food restaurants. When you live in the city, yeah, I guess that's true. I guess I understand your analogy right there. I like that. I like that way you're thinking. I'm gonna hide this because every time I just can't see people. You then want the serenity and the manual labors of the rural village because the sea has disconnected you from the nature. That was beautiful, man. That was absolutely beautiful. And I'm gonna screenshot this because I am definitely gonna do a tweet. I'm gonna credit you on this, dude, obviously, but it's a beautiful take of as to why people love doing low-level languages. But yeah, dude, beautiful, 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 beautiful. And I agree, by the way. I actually grew up in a big city, right? So I never knew what rural kind of feels like, but low-level programming makes me feel that way, I guess. So yeah, what could be going wrong here? So we take the IO stream by reference and the job number. I do wonder. See out guard on IO stream. I mean, I'm not entirely sure why this would kind of not work. Okay, so we have more stuff here. So in the terminal, I guess I can clear this, and let's see if we can just debug this, because I want the program to be running fine. Right, I want it to be actually running the way we think it's gonna run. The problem is that address sanitizer doesn't actually give me anything nice, which is annoying. Very, very annoying. Thread local quarantine size. Dude, just tell me where the freaking memory address access was invalidated, please. That's all I want to know. Thanks for the compliments. My cheeks are red now. Dude, this is borderline, not PG. But yeah, no worries, man. So we take in a vector of parameters here. Yeah, in this case, we don't really care about the parameters. Yeah, and then each kind of worker sleeps for 50 seconds before saying hi again. That's essentially what this does, but I don't understand why there is a memory access issue here. If I just had one worker, right, you can kind of see that it's not going to complain now. Oh, yeah, I mean, I've not built, right, so it is definitely a multi-threading issue. Oh no, it still really complains. Like, why? Is it something in the thread safe queue? I am kind of like wondering now. If I just run the program with no queue, and there's still a leak somewhere. So it must be whatever we're creating the thread pool. So threads.pushback. What is threads in this case? It's a JThread. Yeah, and the JThread is just a joinable thread, which means that when it goes out of scope, they just get joined. And the tasks queue, right? Make thread handler of queue. You know, when you look at your code from like a year ago and you're like, what the hell? That's what I feel every time. So make thread handler takes in the queue here, and what does it do? Returns a JFred. Yeah, so this is returning a C++ thread, which is kind of running this lambda here, and that lambda captures the queue itself. So in fact, this might be the the basic issue here. It captures the queue, and while we do a queue.pop. So what is my queue.pop? So my queue.pop is a unique lock, and it has some condition variables to signal whenever it's safe. So we wait until we can pop an item, right? So whenever we push an item here, you can see that I select the mutex, right? So I acquire the mutex for the queue, I push the value into the queue, and then I notify exactly one thread that the thing is working. Now, what happens here in this case on the pop is I acquire the same lock in the unique lock, right? And then I call the CV way. So what a condition variable does in C++ is like you've got a lock that's acquired. What it will do is it's going to release the lock and wait until this condition is met, right? And once that condition is met, it's going to reacquire the lock and run the remaining of your logic here. So that's, 101 condition variables for you in C++ if you guys have never done it. But in this case, I don't really see anything that could be wrong with this, to be honest. This means that we kind of have the locked mutex here for the queue, which means we can safely kind of pop it, take the front and pop the element, and then return the return value, right? So of course we're explicitly kind of copying the element here, and I'm fine with that. But is this actually what the problem is? We can check that, right? We can check that by simply commenting this out, building it, and running and see if it's still going to complain. Because obviously address sanitizer is not going to give us the issue. So, that's not the issue anyway, and we can see that there. So exactly what is the issue? This is actually running what I think is running, right? So we are unit debug tests. So unit debug. Select configure preset, and we have Unix Ninja Clang debug. Unix debug Ninja, yeah. Okay, so this is what I expect to be running on my build. So build Unix debug Ninja tests. No, yeah, I'm not running the tests. There you go. Right? Yeah, thread pool app is here. And that's what I'm running here, right? So test thread pool app, yeah. Yeah, so I am running the thing. I'm just making sure I'm running the right executable before I start trying to debug and it's not the right thing that I'm building anyway. Because that would be quite embarrassing, wouldn't it? And we've definitely never done that in the stream before, but yeah. So if we comment out the thread pool, yeah. So now we have basically nothing. We have absolutely nothing in the program, and this should just run. Wait, why do we still... I'm so confused. What in... Make mock tests. Let's put a breakpoint here. Is it actually running that? What? Encounter the fate. So it's actually not complaining about my code. It's just a false positive. That Schrodinger's bug is definitely it's both there and not there at the same time. Indeed, yeah, man. What's more interesting is that I'm gonna save this before I forget. By the way, just write the name and realize I haven't actually saved this. Ooh. So I'm gonna save a screenshot. Arconaf. Butte. There you go. Now I can close this. Yeah, it's interesting that it's actually just failing when nothing is happening. So is there anything that I'm like creating statically that could be the cause of this? So like if I don't include this header and I don't include any of this, and then I just build and run, it still encounters a fatal error. Like, what is the issue here? What is the issue? Why is it giving me false positives? On the Clang version 10, blah blah. Am I just not including the lib Asan flags correctly? Because I think that's probably the issue, you know. So it will be some of this, I guess, right? Let's see what the error actually is. So, right. Registered region, unregistered region, failed to intercept this. So this is really the problem we're looking at. And this is not a problem with our code, which I'm much less worried now, but I still want to fix this. But like, what is the fix? What is the fix? Because like, what are the flags that we have into CMake presets? And we have Asan, lib Asan, address sanitizer. So yeah, we got address sanitizer here, running for Clang debug. Now I do wonder, is that everything that I need? So address sanitizer, Clang flags. Yeah, is it not able to load anything here? I'm interested now. Symbols loaded. Using lib thread. Do you want to take a look at my cheat sheet of all the things I need to remember for the exam? Yeah, let's do it. Post it here. I will keep my Discord open for when you send it to me. But in the meantime, let's make sure that we can fix this issue. Like, dude, come on. There must be a way to just, like, what are the flags that I need here? What are the flags that I need? I got your message, dude, and I will be checking that out real soon. Just give me 1 minute. Well, before performing actual leak check, Asan spawns a tracer thread to attach the program on the ptrace. It seems that Docker unprivileged ptrace can fail. Okay, so is it because I literally don't have root enabled and it's not gonna be able to? That can't be right. So if I run thread pull from here, nothing really happens in this case. But if I run it through VS Code, then something happens. Okay, yeah, I mean, it must be something wrong with VS Code trying to attach itself to things. It's in Swedish, but I think it can still recognize a lot of stuff. Right, let me see. So this is Robin's exam cheat sheet. Let's see. I mean, it's been literally, quite literally, like years and years of not doing. Oh, the resolution is not great, Robin. I'm not gonna lie. But yeah. So we've got some polar coordinates switching here, and I can't really read these things very well, but I guess you are playing with function mappings or something like fields, vector fields, I don't know. Oh, the divergence, yeah, divergence of f. I remember that shit. Yeah, this is the Jacobian shit. I do remember this. It's good quality. Open in browser. I am open. I'm open in browser. Look, this is browser. This is browser. Ah, okay. I see. Ah, okay. Yeah. This saves my day actually. Right. So this again is more integration stuff. This is the geometric series sum, right? Stuff. And you've got the chain rule for calculating derivatives and stuff. I believe it is. The chain rule? Yeah, I think it is the chain rule, right? That's what we call it in English anyway. I do remember this one, but I don't remember what it is. And then, yeah, sine and cos. Is it a no calculator? Like, you're kind of remembering a lot of values here for sine and cos. I remember it's a no calculator. I assume it's a no calculator exam. Is that correct? I used to, yeah, good. I used to love those because the thing is, with me, I can remember, I could remember values of, well common values like these ones fairly well. And I knew how to get like arbitrary values for sine and cos depending on kind of like the combination of these values that I could have of the inputs. But if I'm doing it on a calculator, I will get things wrong because I'm typing it out. So yeah. Gotta go. Wish all the best with your environmental problems. Might drop by later. Thank you, Arkanaf. And yeah, man, I wish you a nice evening as well, man. I hope to see you again in the future. Yeah, best of luck, Robin. I'm sure you already understand most of it, right? So just gotta remember things now. Yeah. So the problem here is that we are just possibly going to ignore everything, right? So let's get into the problem. I'm fairly confident that this implementation of the thread queue is fine. So let's uncomment everything that we had and kind of load that little program that we had again. Yeah, it's basically just an issue when I run it through VS Code, which must be an issue with WSL, not letting VS Code attached to random programs for debugging. I don't know. Something to do with pthread, but I'm fairly confident that it's fine anyway. Now the thing is, we had thread pool here. I mean, it's good and bad. You can kind of tell if you go the wrong path because it's supposed to solve itself easily. Yeah. That's what I used to like as well about non-calculator papers. You just, if you got something fucked up, then it's not right. So you can go back and then see where you got it wrong, but only if you have time, because I'll give you a very good advice right here, Robin. So there's one exam I did very bad at, which I got like 50% or something. That was the worst grade for a maths exam that I got ever. And the only reason I got that is because I was trying to fix the question I knew I had wrong because of what you just said there. I got something like fucked up and I was trying to fix it because I was like, yeah, this is easy. I've seen this multiple times. I can do this. But then just time went by, 1 hour, an hour and a half, and I'm still on the same question, one of like 3 questions. Don't let that happen to you. If you got something wrong, just skip it, go to the next question, do that. And then at the end, if you have time, and you're comfortable enough that you got the other shit right, go back to the question and fix it. Yeah, never do that. I'm very stubborn. That's my problem. Learn the hard way first year. Yeah, indeed. I mean, unfortunately for me, in the first 2-3 years, I did actually fairly well in all the exams, but that happened on the 4th year. So yeah, on the 4th year, I had to learn my lesson there. It could have been on the 1st year, but yeah. Oh well, unlucky. Things happen. Yeah, so I think we can build this, and I think we can just ignore the safety issue. So address, wherever we have Unix debug ninja here, we're just going to remove address. Yeah, I don't really want to play with this at the moment. I don't want to have to figure that out. So my pool is commented out. That's why my biggest flex in life is that I got the highest grade on my calculus 1 and 2 exams. Nice, dude. Yeah. Unfortunately, in maths, I never really got any of the highest grades because I may have in one or two of the modules, but I didn't know enough people in the module to ask. But I did get like a few, like 89% or 91%. But yeah, unfortunately, maths, they were always kind of lower than my computer science exams, just because I did a joint course. I did half computer science and half maths. So I was competing with people who would do 100% maths all the time. So they were much better than some of the stuff when compared to me, basically. Okay, so we got back the program. The address sanitizer thing was just an issue. Let's actually include MIO right now, right? So let's read the file. Let's read the file. So MIO. Okay, so we've got the memory source using the constructor. Okay, how to create a memory mapping. So using the constructor, which throws a stud system error on failure. Yeah, so we're gonna do this. Path, offset, and size to map. Ooh, this is beautiful. I've already got some beautiful ideas here. Because my idea, right? Let me see if this makes sense. So you've got a big freaking file, right? Big file. This is the text file, right? Boom. This is my text file. I'm gonna get each of the workers to kind of run a little bit of it, like read part of it, and then the rest of it will be done by the other workers, right? So that's what I want to do here. So something like this. Okay, where is... Dude, I love Excalibur, but it just takes so long for me to create anything useful. So this chunk of the file is going to be given to my worker 1, and the same thing for the second file, and the second chunk, and then the same thing for the third chunk, right? So we're gonna have workers there, which are kind of reading the thing. So say we have a worker here, worker 1. Programming is more than maths. Yeah, I mean in the real world, yeah, 100%. Like you can get quite a few jobs with programming. You can't get that many with maths, unless you go into academia, and they don't pay well anyway. But at university, knowing maths is much better than knowing computer science, though, because you can kind of just do any engineering degree or any computer science degree if you know maths well enough. So that's the plan here. So like I'm going to read part of the file, give it to worker 1, and this worker 1 is going to calculate all of the information for that chunk of the file, right? And this, in theory, should be running on each thread. So I can divide this file into however many threads I've got in the system, right? So that's what I'm going to do. That's why I'm using the thread pool, which is good because memory IO already gives us a way to do that. So all we have to do is calculate the offset that we want to load. So yeah. This feels like a copyright strike. Why does it feel like a copyright strike? I don't know. But if it feels like a copyright strike, I'm gonna skip the song. Yeah, let's include MIO now. So we're just gonna let's just work from this app, shall we? So you got thread pool here, and we've got MIO. Let's also add a find package in here. MIO required, and we've got MIO found for us. Beautiful. And in here we should be able to do something like include MIO and map. Okay, and let's map that file in. So file is going to be mapped in here. All we need to do is get the path. So stud string. Wait, what does this actually take, by the way? Let's find out. So, dude, there's so many type defs. Come on. There's a structure which has private, and then it has public basic map default, and there you go. So it takes a string. What is a string? Type name string. Okay, so it's actually, it can be any string that you want. Kind of nice. I guess that string has to have certain things to it though. So what is it? String path. Put into map here. A map again. Handle type. What does handle type have to have? Come on. Handle which must have a valid file handle. Okay, no. Map entire file. Okay, yeah, let's just do that, I guess, right? So, yeah, let's get the file args here, and in here we're gonna do if argc is, I guess, well, not equals to 2, right? We want 2, and we're gonna do a return -1 here, and we're also gonna do a stood out, a cout. Invalid argument number. Valid number of arguments. Okay. And our path is going to be a stud string const there. I guess. Let's work with these const, shall we? File path. That is going to be argv, because we know it's exactly 2. And the offset, let's put it to 0 here, and then the size to map. Now this is the thing. How do I map the entire file? You can omit the offset map. Okay, yeah. Easy. Okay, so what can I do with this map, this file map? So that once we have our file here, I want to be able to look into it, look into the file. Print all lines, right? Let's do that. Using the factory, or yeah, what can I actually get with memory map here? So guess what, Robin? IntelliSense is working beautifully. Do you know why? Because I have 0 modules in this and it just works so much better. Look, mmap, I've got all these functions available for me. Like, what a luxury to be able to tell. So I want to kind of... So what information do I get? I get const car. So I guess I can read into a new line, right? And that could be one way of doing things. We can go line by line, and that's kind of what we're going to have to do anyway. So I guess we're going to read until we have an end of file, right? Do I have a size? Yeah, I have a size of the file as well. Interesting. Yeah, so I have the size of the file. Let's say I wanted to just like read a line here. So how would I do that? So is it possible? Is there an efficient way of doing that, or do I just have to read character by character? Which wouldn't be amazing, to be honest with you, if I'm honest. Oh, we have a type by here. Amazing. Let's see if there's already someone who's asked how to read a line. Okay. Yeah, I guess there's no way of like actually reading a line for a file. So we're just gonna have to read string by string until, I guess. So if we do start stud size t I offset equals 0 until the offset is less than mmap dot size, right? What do we have here? Size t, yeah. Plus offset. I'm gonna keep this as basic as possible for now, then we can think about the optimizations. And what we're actually gonna do is we're probably gonna have a string builder. Or I guess no, we're just gonna find the offset here. So I guess if the map is there an at or something like that operator? Okay, so we do have the operator this. So if the operator offset is exactly a new line, right? Ooh. And then we can do stud size t here as the previous offset. Start with 0, you see why? We're basically going to substring, right? We're going to kind of get all the values here. Is that going to be faster than constructing the string anyway as we go? I don't know. I really don't know. I'm also, to apply some optimizations here, if we take a look at the file, like what is the maximum string size that we can get? What is it? So this is the file. And I kind of want to see the maximum string that we have here. So what is it? Some of them are pretty big, don't get me wrong. So this one is a pretty big string, right? And that's, oh, there you go. Another one that's really even bigger than that. Always trust the Spanish to have, the Spanish and the Portuguese to have the biggest names you can possibly think of, by the way. And this is coming from someone who is both of those nationalities, by the way. This is not racism. But yeah, this one is the biggest one so far. I can kind of see some of them here that look interesting, like this one. Nah, that one was still bigger. That one was still bigger by far. Like this one here. So say, you know, say we can have double of this, right, as a size. Because what I'm going to do is I'm going to allocate an array on the stack, which is going to be caching all of the things here for me. Why did I not copy that? Copy. Awk print. Will that work? The thing is, this has got a billion lines, mate, so it probably will, but I don't know how long it will take. Shall we see? So awk, let's see what if that, yeah, print line name input file and sort by yeah, no dude, this is gonna take a a lifetime, but yeah, let's see. So our input file. So my input file is actually in MNT, C users download. Weather stations, right? I mean, it's a good benchmark anyway, so let's see how long this takes. I mean, I'm gonna let it run for a good 10 seconds, but I guarantee you this is not gonna finish within our own stream time here. Let it run though, let it run in the background. Yeah, it's sifting through a billion lines, so yeah. But anyway, what was I gonna do? Yeah, I was checking how long the longest line that we have currently is. My computer's working hard. I'm not sure if you can hear the fan, but it's working hard to read that file, my man. Character size. So this line here is 53, right? Say we have 100 maximum. 100 characters is the maximum line. Why do I do that? Well, because we can create a little... Where are we? This one. We can create a little array here. So it's a third array where we're going to hold a character and 100 there, right? And this is my string builder, right? And why am I doing this and not using the string builder? Well, because this is actually on the stack, so it probably is faster and it's not reallocating memory every now and then. So I want to avoid those operations to make it fast. So it's still go. Ooh, there you go, dude. It worked. How long did it take? I don't know, but I'm gonna time it again. So is it time? Yeah, I'm gonna time that shit. So this is the biggest one we've got, and it's 60 characters. Yeah, I mean, I'm still gonna leave it at 100 here, just because I wanna make sure that if people put up to 100 string, 100 line, 100 character lines, it's still gonna work, right? So if it is, okay. So if we found a new line, we basically have to submit a string, right? So let's do a stud vector of stud string here, which is going to be my lines. And an important thing to note here is essentially like, oh no, let's not do that. Yeah. I came back seeking help for an urgent and most dire problem I'm facing. Go on, Arconaf. Mate, if it's programming, I can help you, but if it's anything other than that, then just be ready to hear my bad advice. That's all I'm saying. Yeah, so let's see if we can... I have to code the shopping system for the game, but I'm missing a very essential component, the music. To listen to while code. I think Robin is your man, actually. So if you talk to Robin, he'll be able to give you some good coding or streaming music. The one I'm currently listening to is this one here, dude. I guess it's fine to share with him, right, Robin? But yeah, this is the one. So can we share the link? Can we share the link? Am I just being blind? Like, where is the link? Where is the share button? Don't they want you to share? There you go, share copy link. I have consumed every single bit of lo-fi instrumental. Same with me, dude. I'm gonna do a mem copy here. So is mem, I want to zero out. You know, I need to zero out the string. In this case. And we're basically going to use the fact that whenever C++ encounters a binary 0, it's the end of a string, right? That's what we're going to do here. So this song sucks though. I'm going to move it. There you go. Nice. I kind of like the Michael Jackson style. Wait, what is it? Thunder Snails. Nice. It kind of feels like we're gonna get a copyright strike for this, but I'm happy to leave it on here. So yeah, we're gonna use the fact that whenever we encounter a 0 by on a bit of memory, that indicates the end of the string. So I kind of want to just copy memcopy 100 bytes. So stud memcopy. You're using the wrong playlist though. I send you a version that created before. Oh, scheiße. Oh. Okay, yeah. Thank you, thank you. A less copyrighted song. Thank you, Robin. I thought I was using this one, so it's Stream Chill. Right, this is the one. Or maybe not. Dude, I've got so many tabs open, like I'm losing myself here. My man can even curse in German. I need to curse in German, so I still have... In fact, do I have ads turned on for this video? I don't know. Let me turn it on now. So if you see an ad, you better not skip it. That's what I'm trying to say, because that's going to get me some British pounds at the end of the month. So please, please do not skip it. Yeah, like, it's weird because the monetization is on by... is not on by default. Aggressive? No, medium. Medium is fine. Oh, come on. Move out of the way. There you go, boys. Don't skip the ads. Please. I'll still be here when they're over. Yeah, so we're gonna... In fact, all we have to do really is set the first line, right? So current line dot 0. We're just gonna set it to 0. That's what we have to do. I've got your back, watching your ads via YouTube Premium, yes. Oh dude, you've got YouTube Premium. It must be fucking loaded. That was a curse, I shouldn't have done that. Yes, I'm one of the minority who have YouTube Premium, so I can play white noise without ads, keep the baby asleep during the night. Nice. And you've got a baby as well, dude. That's crazy. You can do programming, you can watch YouTube, and you take care of your baby, and you have YouTube Premium. That's life completed for you right there. This man has his life completed. That's what I can say. I need to get some advice from you, my man. I have YouTube Premium as well. Jeez, who's not got YouTube Premium? Am I the only one here? Right, so we set it to 0 and we continue. Yeah, I'm fine with that. And if it's not 0, we're gonna do the offset. What are we gonna do? Really, we have 2 offsets here, right? We keep track of... Because we want to do a pushback, so we keep track of the previous offset. Yeah, I guess we can keep track of this string offset, so cur line offset, and that'll be 0 as well. But in here we do cur line offset plus plus, and that's it. And I mean, ideally, right, I can just do this. I mean, this is even easier than that. So for, I guess, character C in the memory map, right? That's what we have. That kind of works as well, doesn't it? And then we can do all of this inside here. Let's close this shit. So if the character is no, we have that. Otherwise, we have the character at the current line offset is equals to 0. Oh no, that was right. It's equals to 0. but the current line offset will be reset to 0 as well here. That's what we want. And then that is going to be C. So let's see if this is actually reading what we think it's reading, right? So first of all, we can build this. Shouldn't give us an issue. And let's pass in that file to it, shall we? Please, I feel like a junkie. That's on a long dry period and I have all the symptoms of withdrawal. I need the goods. I posted the link before, dude. It's already there. Chat, it's here. Yeah. I posted the link. Just go back up. It's in the chat. It's in the chat. Yeah, do we have a file read? Right, so now we just have some arguments. We need to pass in the file here. So let's say we copy the file over, right? So we have, I don't know. Let's move this to workspace there, or workspace folder, I believe it is. And then in here, we can do workspace folder, and then 1billion.txt. Or .csv, I don't know what it's called. We're gonna copy it as CSV anyway. Right, and then this is where we can come in here and kind of copy from my Windows. It's weather stations, that's what we... Okay, weather stations, that's what we're gonna go for. Going to my main file. Can we debug this? Let's see. Okay, so, okay. The length is very big indeed. So this is how many bytes we've got. Let's see if it matches what we expect. 175 megabytes. You can see how fast that call was, right? So like it was less than a second, well, less than a millisecond probably. So this is how many, oh no, bytes to megabytes. Yeah, this matches what we kind of expect, 184 megabytes, which is, wait, what? No, we want bytes to megabytes. What the hell am I doing? Megabyte. We have byte. There you go, 184. Is that what we have here though? So no, it should be 176 megabytes. I have no idea why it's giving me 184, but we're fine, right? Let's just hope it works. Yes, Robin, consuming the music along Tino. It started so good. Consuming the music, that feels dirty to say, I'm sorry. But yeah. Running. So what do we have here? Current line, M elements. So yeah, we're getting it. Yeah, we're getting there. And guess what? If I wanted to kind of put all of these things into a vector of strings now, right? It's very easy. It's very easy indeed. This is what I have to do. See, but this copy is probably very expensive as well, so I kind of prefer the previous offset, to be honest. Guys, don't forget to like the stream. Yeah, don't forget to like the stream. Yes, thanks Robin, consuming the music is okay. Yeah. Read everything. Yeah, please like the stream. This is going to be interesting. Maybe we're going to stream until 11 or something today. It's a Friday tomorrow, right? So maybe I'll do a double stream. Who knows? Maybe if we haven't got anything here, we will still do the same thing tomorrow. Yeah, if I wanted to put if I wanted to create a vector full of lines here. So what do? I can do a vector itself of strings, and then I'm going to say like all the lines, something like that. it's just a proof of concept to see like how you can map these things. Why don't I like this bit of code? Because this bit of code is still doing some unnecessary copying to my array here, right? So this is what I'm kind of doing. What I really just need here is the offset. I need 2 offsets. So I'm going to take this back into the size t loop, right? So size I equals 0, I is less than my mmap dot size, and I do plus plus I, right? Why am I doing this? Well, because then I can avoid the array of copying, and I can copy it straight to a string that's going to go straight into my lines here, right? And to make things easier as well, like all lines, I'm going to reserve some memory. Now, how much memory am I going to reserve? How many lines do I have? Well, I have 1 billion lines, right? So this is literally enough memory for this many strings. Basically it, right? This is basically it. So when I do pushbacks, it won't be like moving all the pointers around. In order to like it, I have to dislike first, which I can't bring my heart to do. I wish YouTube worked like that, where if you dislike it and like it again, it would just count as 2 likes, but unfortunately it doesn't. In fact, the best measure for YouTube today is watch time. If you guys watch it as long as you can, that's what helps out streamers the most. Likes don't really count for anything. An example of this is one of my shorts I made where I said something wrong about using timestamps, American timestamps, when really it wasn't an American timestamp. It was like year, month, day timestamp, basically. And then all the Americans commented on the video and disliked the video saying that it was wrong. But still, it's one of the videos that I got the most views on and most watch time because they interacted and they watched the whole video just to complain about it on the comments. So yeah, this is how you kind of gain views on YouTube as a coder. You do like certain mistakes every now and then and people will engage and you will get tons of views. So yeah. And this is what like big streamers do, by the way, 100%. I know quite a few of them who do this exact thing that I've just mentioned here. Yeah, so why don't I like this? I don't like this because we have this. So I have the previous offset. What I want to do is I want to make a all lines dot push back or in place back. And in here, I'm going to take the pointer itself, which is map to I here. And this is what we're going to do. And the size of it. So the size of it is actually kind of very easy, right? So we have map I. So we want, actually this is what we are now. So we want to go from the previous offset. Wait, what does memory map have? Can I get a slice of it somehow? Can I have a slice of it? No, just begin and end. That's fine, we can work with that. So we can do this dot begin plus the previous offset up until we have mmap dot begin plus I. All right, that's what we want to do. So this should always work, hopefully. And this is the whole string. We're placing it straight into the vector itself. And now what do we do? Now we set the previous offset to be equals to the current offset, which is I. And then we continue. Simple as that. And that's it. This is the for loop, a little bit easier now. Let's see if this is gonna work. I've probably just written like 10 different memory bugs here in C++ because, hey, it's C++, right? Okay. No memory issues, come on. So this is how long it's taken to go through the entire string, and it's quite long, by the way. It took quite a long time, didn't it? It takes quite a long time. So you can see here, my size of, I've got all the lines here. And you can probably guess that I also have got the new lines here, which isn't quite right. Yeah, it's not quite right, is it? Why does he only go to... Wait, what? What's the debug console? So if I do all lines dot size, there you go. So I have this many: 1, 2, 3, 1, 2, 3, 1. So it hasn't done all of them. Why hasn't it done all of them? Because this should have done 1 billion lines, and we only have like what, 9 million lines? It's not quite right, is it? So how many? Oh yeah, that's because I don't actually have 1 million lines. I have 10 million lines here. Yeah, so that's fair enough. I mean, I got it wrong. That's fine. Let's see if I can change this. Yeah, but you know, bug number 1. We didn't go through all of the lines. We did not process the first 2, did we? Let's run this again. By the way, it's quite slow because we're running in debug as well. That's why it's lower than it needs to be. So all lines. We have Tokyo twice, so it's doing that one. But the very last one is what? Yeah, I mean, it's not going to show me, is it? So we need to look at all lines. Dot size. So this is our last element, 99999. Right, so what's not going on here? I've got a very quick test we can do. So the first 2 lines have been passed correctly. The last 2 lines are not being passed correctly, and why is that? Why is that? So we have in place back, all lines don't in place back. And this is just working through each kind of array. And this should fix, this -1 should kind of fix that issue of having an extra line. But we don't yet fix. Ah, I see. Okay, yeah. Yeah, it's understandable why it doesn't work. That's because we kind of need the extra line here, right? So we need to have this there. Oh god, I'm adding something to the file, but like I've pressed enter and my computer just won't let me add that extra new line to it. Yeah, it just won't let me do that, guys, unfortunately. But maybe if I do on WSL, is it gonna let me? I don't think it will either. Open anyway. Hello, Al, how's it going? Good to see you, man. We're tackling the 1 billion line challenge. So can I do this? I just want to add a new line to this file. See, the file is so big that I cannot do the whole thing. Echo new line file. Yeah, I could do a new line, but I don't think it's gonna work. Like, does that work? Yeah, that works. Okay, that did work. It's actually faster than. Now, did it actually add the new line? Yeah, I've got 2 new lines now. But that's fine, right? I think what's happening is like my editor is being so slow because it's sifting through all the data here. That my commands do actually go through, but they just don't show up because it hasn't realized that the file has changed. Cat file tail. No. Less. Less, and I think you do a reverse of the file. I guess we can do cat. Weather station. See, the thing with cat is that it's actually going to open the entire file, so it might not work. So yeah, we do have one new line now. Beautiful. So cat doesn't actually open the whole file. Well, it should do. Anyway, running this program now is going to probably work the way we expect now. So we're not going to have the new line in each of the files, in each of the lines. Okay, and things are, I don't know why they're faster. They seem faster. 1, 2, 3, 4, 5. There you go. So the vector should have all the shit that we expected. Oh no, we still have that. We still have the new line. Why is that? If the map I is a new line, I thought I rebuilt this. Did I not rebuild this? Let me put a breakpoint here and see what's going on. Yo, do you know by any chance if I need to know anything about machine learning or similar things, if I just want to use some pre-trained model for image recognition? No, you don't need to know anything if you want to just use the model. But Sop, I think that's you, right? Welcome to the stream, dude. What I recommend is actually going on, if you want to run it locally, try running things from the Hugging Face. There's a bunch of stuff that you can download, a bunch of models you can use. So just take a look at the data, at the models, and click on like text to image. I think that's probably what you want to do, right? And then see whichever you can actually run locally. I will say that some of these models are quite big, so you got to look at the size that they have. So for example, Stable Diffusion 1v5. If you look at the file sizes here, you can see that the model itself is 8 plus 14, that's 22 gigabytes of RAM. So just make sure you have enough space to run this thing. And I'm not sure if it runs everything in memory. I don't think it does, but you might want to be sure that you also have enough space in your RAM to load these models. So that's the only limitation here. But you don't need to know anything about it if you just want to run models. So Tokyo was that. Okay, so next one. So all the lines currently is Tokyo, and now it's a Tokyo with a new line. Okay, what is going on here? So if it's the new line, then the previous offset. Okay. So it's going to be that plus 1. My bad. If we build it now, we should be fine, right? Okay, so all lines, there you go. We no longer have that annoying new line here, right? So we've got all the, in this case, it's 10 million lines. That's what we have. I do wonder, like, how fast does this actually take? So let's, for now, I'm gonna comment all this shit out, right? Now let's down here just print out, so std out. We have so something like this, right? If we do this, build it, and I want to actually just build this in a release, and you can see like the massive difference that we have here. So Unix release, so it's Unix release, Clang release. There you go. Okay, so we just need to install Conan. Yeah, this particular compilation has no kind of optimizations turned on. It's 0. That's why it's very slow, by the way. But yeah. Oh, please. Just work. Just work for me, please. Please, Conan. Pray to God. Okay, beautiful. It just works. Okay, good. We should be able to reconfigure now. Hopefully, yeah. We found Conan. Praise the sing hymns, and your machines will work. Yeah, man. I managed to build Qt debug with only 1 error. I feel like buying a ticket. I managed to build all these things with no errors now, so who's the lucky one? Yeah, but these libraries are quite small though. Let me build this and... Ooh, mutex IO stream, unused variable. Yeah, I don't care if it's unused. I do care because it's actually gonna... It's not gonna let me compile, right? Okay. So now if we change this from Conan debug to Conan release, and we just run it so you can see how fast it actually is. You see, it's fast. It's very fast. We have 100. Woo. I don't understand why we have that +1 lines, but we do that anyway. Yeah, let's do something cool. So I want to actually time it with... So how long does it take to read the entire file and put it into strings? It takes about 0.68 seconds, right? So what's the current... This is reading all of the lines in the file, and bear in mind this is not a billion lines, this is actually... What is it? 10 million lines? So 10 million... Yeah, 10 million lines, right? So what do we do? I'm thinking what the next step is. We could put file mappings on it, right? So we can split this into however many cores we have. So for example, I definitely have like 6 cores on this machine, so I can run at least 4 threads. Let's pass this onto the thread, shall we? So we're going to turn this function into a... we're going to turn this into a little function where we're going to read the file in parts. That's what we're going to do. Please 10 million and 1 lines. Don't understand audio performance, even at the rate of a fraction of a second of 100. It's just C++, dude, and some common knowledge. The thing is, this is not optimized at all. This is the lazy solution. We're just getting something working today and making it faster and faster. So yeah, let's do that. So we have a function. Let's say we have a function called read lines, right, from offset, and we have the whatever this type is. So MIO map source, and we have file, and we also have an offset, which is a size t. And what we're going to return is a vector. So we're going to return a stud vector of lines, which is a string. By the way, we're not going to stick to vectors of strings eventually, because you can probably guess it's very it's not very efficient to have strings all around. We're probably going to change to string views or something that doesn't require kind of copying everywhere. So read lines. What's the issue here though? Cannot overload functions distinguished by return type alone. What? Like where is no references found? Yeah, there's no references found because I haven't defined it yet. Okay. It's mmap source. Mustard size T. Okay, that should be a bit better. Unused file. Yeah, okay, so we have some errors. Let's move all this here, right? Let's move all this stuff into here. It's about to get even faster now because we're gonna bring on multi-threading into this. Gotta go again. The baby's asleep, the music is good, and the tea is hot. Stars are aligned for me to actually code properly. Arkanaf, have a sick coding, man. Don't forget to drop a like, but it was nice seeing you again, dude. And I expect to see you next time. And bye-bye, man. Have fun coding. So, okay, mmap. So this is just gonna be the file, I guess. File there. File there. Now you may be asking, is this a threading issue if we're accessing the same mmap source? And to that I say yes, it is. It's probably a race condition at some point if we're changing values, but we're just going to read them. So hopefully there's not going to... I say that, but in the other 65k stream that we did, there was definitely some weird behavior happening there as we read things, but yeah. It's just gonna mute, so YouTube premium page. Thank you very much, Arkonaf. That you know, you are a true supporter, and I appreciate that. I will return that favor at some point. So we're gonna reserve however many lines we have. So okay. So n lines is the number of lines that we're going to read, right? So we're going to basically do an n lines here. Or is it? Or is it the number of lines that we're going to read? I'm quite interested now, so... So yeah, we've got to place that back anyway. But then here we've got to do a check as well. So we've got to check that all lines.size is not equals to n lines, right? So if it is equals to n lines, we're done here, basically. I think this could be a solution. I mean, there's obviously some boundary issues that we're going to have. Like, we're going to tell this function to read a chunk of the file, but we can't really say like whether or not the chunk is going to be starting at a new line or not, because it's going to be a byte, right? We're just going to divide the number of bytes by 4 and pick the closest character. But I'm willing to let this go for now, and we'll be able to see how this is going to work soon. Hello Slim, how's it going? Dude, we're doing what you suggested. I think you're the one who suggested this, so like I'm actually taking a crack at this. So yeah, so as I said, we can't really know for certain whether or not we're going to start on a line, so there's going to be some code here to actually check if we started after a new line. Alright, so that's what we're going to basically be doing here on the file. Or in fact, it's going to be outside here somewhere. You're finally doing this challenge, yeah. So far we can read the entire file in 0.68 seconds, but the file is only 10 million lines long, so it's not quite a billion yet. I mean, we're still doing some optimizations here. New Jägermeister update just dropped. Orange flavor is now available. Jägermeister is such a... It's funny you say that, Robin, because you are a university student. And in the UK, Jägermeister is only consumed by university students, so you're doing it right, dude. I kind of consume no alcohol now. I'm too old for that shit. So whenever I drink, it's just I just wake up with a headache. So I try not to. Basically, I've done my fair share of drinking in the past, and now I'm clean as hell. And because we're talking about this, I'm definitely gonna. Well, this live stream is gonna be not suited for everyone tomorrow. That's what I'm gonna get from YouTube. Like your monetization is only partially enabled. It's not friendly to advertisers. I love when that happens. I already don't get a lot, by the way. I get like a tenner every month from YouTube, from like the few ads that people watch. And then some of the really cool live streams that I do get just demonetized straight away. And it's lovely when that happens, but yeah. Anyway, so all line size. Vigo, what do you think about Emacs? I never used Emacs, to be honest. However, I've known some pretty good people who have used Emacs. I've got no opinions on this. I like Vim. Vim tends to be the one that I use for like terminal editing, or just on VS Code as well. Like I've got Vim bindings here, but yeah, I mean, pick what you want to choose, dude. Like it really doesn't matter. Like people have too many opinions on what editors you use, your coding style, and at the end of the day, it doesn't matter. Whatever you're happy with, just go with it and stick to it, man. That's what I can say. I used to have more strong opinions on these things, but I don't worry about it too much now. I'm struggling to think what I was actually kind of gonna do here. So if we have read that many lines, like I want to know when to stop, right? I want to know when to stop. We're gonna return vector. That's all. So all lines. My friend uses Vim and I use Emacs. We debate each other over it often. Yeah, I mean, you can do that, or you can also kind of be friends and enjoy life a little bit more, because these things are not worth debating over. I mean, you know, I pick whatever I'm more comfortable with, and I wouldn't be able to pick Emacs because I've never learned it, so I don't really have any opinions on it. I can't really shit talk it, but it's for the best, probably. Vim and Emacs is like iPhone versus Android. Yeah, I guess it is. I honestly don't see why people care so much. Like, I just use one of them. You know what I mean? Do whatever makes you happy. Yeah, indeed. I use Nano, bro. Let's do a Nano typing competition. See who is faster at that. I'll win. I'll tell you that. Can you even exit Nano? Because I can. Like, geez, Nano, yeah. Oh, yeah. Now I'm like having a massive debate over like how to stop this, because I'm telling this function to read the file from this offset until when? Like end offset maybe. Let's keep it as that. I hate how much the ComSec people try to measure everything. Yeah, me too. And it's just so stupid sometimes. Sorry, Vigo. I'm not trying to like bring it down or anything, dude. I think it's, you know, if you want to debate Vim versus Emacs, I think it's fine. What I'm saying is like you shouldn't really care about those things too much, if it makes sense. It's like the performance talk. Good that we're touching on this, by the way, because this is a performance stream. We're trying to increase the performance of something. But do I do this shit at work? No. Like, do I care so much about performance that I'm going to optimize every single PR that I see and I write? No, I just want to get things worked. And it's one of those things. Like, let's talk about it now, right? I'm worked up now. I'm worked up. Let's get rid of that. Let's get rid of this. Let's get into Xcali draw. This is the best thing ever. Say you're making a feature for your company, right? I don't know what. I'm going to try and come up with a quick example here. So you work on a company that does machine learning for the sake of being trendy, right? And you're implementing or you're trying to deliver the shiniest and the best like language model, a very large language model. And there's a bunch of work around the app, and you're developing that, ChatGPT user interface online. That's the context here. Does it matter if you create an application that can kind of handle like 1 million requests per minute, shall we say, and is optimized to the bone compared to doing the same thing that just works but taking half of the time? So say me and you work for 2 different companies doing the same thing. So this is, company A, company 1, and then company 2, right? So I'm working for company 2, you're working for company 1. We're doing the same exact thing, and I've got a typo here. So I work for company 1, you work for company 2. Let's change it over. We're doing the same exact thing. I'm on company 1 and I'm doing the same feature as you, and I'm taking twice as long. But my thing is so much better than yours in every single way. It's faster, it's 3 times as fast, 10 times as fast than yours. And it looks better as well. And it just works in the same way as yours, but just better, right? It doesn't matter. It doesn't matter because company 2 has finished it before you. So company 2 has got the application out, let's say 2 or 3 months before your application was out, and they've already kind of trapped all of the customers in their application. So everyone started making applications using their SDKs, using their API calls, and they're not going to switch just because your company came up with the same thing but a little bit cheaper than my company, right? Because in the meantime, while you were still optimizing your shit here, I'm coming up with a second application that's much better than the first one, and perhaps is even better than your company here. So like, performance doesn't really matter that much, and that's what I'm trying to say. And it's kind of clear that some people, especially the ones that come on stream sometimes, I don't think any of you do that, by the way, just for the sake of it. It's not about anyone here. And just talk about, oh, this thing could be faster. You could implement this faster. It's not as efficient. And to that I say, it's not really important. That's not my priority when I'm making something, by the way. This is actually, like, I'll tell you exactly what this is about. It's about this freaking thing here. Where is it? This is why I'm talking about this, because every single month I get someone either on Discord or on GitHub issues here, or on my blog post saying how slow this library is, when this is not the purpose of this library. This library was created as a base64 encoder for a post that I did for the sake of education. Like, it's supposed to be easy to read, not supposed to be fast. And if your application has a bottleneck on base64 encoding, I'm gonna ask you, what the hell are you doing? Because it shouldn't be a bottleneck. Preemptive optimization, indeed, yeah. So Al knows. So what I was saying, Al, 80 to 90% of the people that watch me are usually students or very young people still learning to program, or university students or something like that. And it's fine, but I'm trying to teach these guys to not overly optimize things and just do things that work, because that's how you keep your job, that's how you help your company out, and that's how you get more pay rises in your career, by the way. Just get things done fast. Right. Now, saying all of that, let's optimize this shit. So yeah. I'm a Java dev, there's no optimization in Java law. But not gonna lie, I came here and talked about Rust and C++, but I chose C++. Yeah, I mean both Rust and C++ can be fast. Like, these two languages can be very fast if you do optimizations. But yeah, optimization, just don't do optimizations until you've got a bottleneck. That's what I can recommend. Right, so we're gonna reserve the number of lines. So offset. Oh, we're gonna probably add a to-do check here, make sure and offset is more than offset. Otherwise these things will just like not work as we expect. So the actual number of lines that we're gonna have is this over I don't know. How many lines do we actually have? So this is the biggest one. So say we have that one divided by 2. So 60. Say we have, yeah. Say this is the number of lines that we're going to have in this offset. Just so we can reserve some memory here and not have to kind of move things over and over again. So the previous offset, do we still need that? That's going to be the offset, whatever the offset is. This is also going to be offset here, and it's going to be up until end offset is met. And a number of lines, we don't care about that anymore. Cool, I think now we should be able to return there's all lines here, right? Now why did we do all of that? Well, we did all of that so we can basically, well, first of all compile this hopefully, right? Yeah. So no, what are we? All lines gone. So we can compile all of this and then put each of those things into our thread pool. So we can now run, we can now look into the size of it, so the number of chunks that we have. Let's split this file, shall we? So we do mmap. We're going to look at the number of bytes that we have in the file, and we're going to divide it by the number of cores that we have, right? So let's, first of all, ooh, no. Let's put this down here somewhere where it actually should be, because it's related to that code. My pool, so we can have a const stds, oh, std size t. Oh my god, can't spell today. Let's say I have 4 cores, and in here we're going to use that number of cores. And this is going to be where I calculate how many chunks we have. So, and this kind of has to be after that, so auto. We can const everything. Great. And now we can kind of allocate, or we can split out this file into different readings, right? So we had, just for the sake of it, we had 0.68 seconds to read the entire 10 million lines, right? Now let's see how fast it will take if we did this in 4 different chunks, where each chunk is read in a single thread. So, right, we're going to change this execution task a little bit here. So we have a task that executes. By the way, I'm using my own thread pool here. If you guys are interested, I can probably post a link in the description. Just let me know here if you guys are interested in reading that. It's a blog post that I wrote ages ago. We don't have a lock guide. We want to kind of avoid locks in this case. We don't really need them, because we're reading the same memory, but we're not actually writing to the memory. So we shouldn't have any problem, I want to say. So job n. Do we need that? No, we don't even need job n. Yes, please, I'm using study Freddy thing. Okay, yeah, sure. For now, go on mattgomez.com and then just go on mattgomez.com, right? Which of you hacked my website? mattgomez.com, there you go. The first article there is this. This is where you can learn how a thread pool works in C++ and how you can implement them. Yeah, I'll post a link here though. Anyway, I'm using this anyway for the thread pool. And what are we going to do here? In here, we're just going to read the lines, right? So we have the file. We need to have the file mmap here. The offset, the current offset. Interesting. So we have n chunks. No, it's going to be a chunk size. So current offset is going to be the chunk size times the current I that I have, right? So that's the starting offset. Opportunity Basics, SLM. I don't know what that means. But welcome to the stream anyway. So that's going to be the chunk size. That's why we start reading from the file. And we're ready for the rest, right? So we have that, we have a start offset, and we have the chunk size as the number of bytes that we're going to read, hopefully. And this is the vector. So stud vector, just alter const. Now, of course, mic is acting up. Oh no, what have I done again? What is it doing, dude? Has it stopped? Let me know. Let me know if it stopped. Has it stopped now? Is it better? All I did was move the wire. Let me know if it's still very bad. Okay, I'm gonna assume it's good. I'm gonna assume it's okay. Yeah, okay. Okay, thank you. Thank you guys. I need to buy a new microphone. I only paid like 40 pounds for this one. And really good microphones are something like 150 pounds, 200 pounds. So maybe once I get my YouTube money, I'll actually buy one. So I don't have to pay taxes because I'm buying a YouTube microphone, right? For the business. So mmap, we have the file here. So why is this not working though? Cannot be referenced as it's a deleted function. So what are we doing? So const MIO. Can I take this as a reference then? There you go. That kind of works. That kind of works. And we don't want to sleep. We definitely don't want to sleep. But what we do want to do is like somehow merge the files, right? Mergeth. Merge the files. So yeah, so merge all the lines. And for that, we are unfortunately going to have to do a lock here. And I'm going to try and avoid locks later on, but I just want to see like how long it actually takes for me to read the entire file into memory. Or read the entire file into lines, so split everything into lines, right? And this is very inefficient because, you know, in the long run, we don't want to actually have to read each character and copy those characters, the line characters, to a vector. What we can do is we can just hold offsets, right? So we can just hold sort of string views to this, and that's what it is. That's what we have. So in fact, we can do a massive improvement right now by just changing this to a string view, and I'll teach you how to do that. So you can move it to a string view here, and every time we do in place back, what we actually do is, I guess we can do begin and the end, yeah. And that still should work for a string view. We're not copying anything, it's not copying any data. Right, so return all lines, which should be a string view, and we have a vector of string view now. And in here, again, we're gonna have all my lines. Vector with all the lines here. I mean, yes, we should probably do an all lines.reserve here. Yeah, reserve. In our case, it's going to be something like 10 million, right? Because that's the number of that's the size of the file that we have currently. But yeah. And merging the files, we need this, but we also need a stud mutex in here, unfortunately, which is going to be the lines lines mutex. And in here, what we're going to do is do a stud.lock guard on the std mutex, where we can just call the lines guard. And that's what it is. And now what we can do here is we can just, you know, get these chunk lines and basically just extend our vector. So all lines Right. What's the best way to do this? So what's the best way to actually, the most performant way to extend a vector? I think is not a pushback, definitely not a pushback. So vector insert, that could be the one, right? So it takes a iterator position. No. There is a back insert kind of thing in, let's see, stud vector insert. Yeah, there you go. So insert at the end value, I guess, or the back inserter. STD vector position, iterator, initialize a list. Yeah, I'm gonna use one of these. I don't know. I just don't know which one it is. We are gonna go for. I think this one here is the one we need actually. So constant iterator position. So it has to be an iterator. So stud back inserter. Yeah. So we can do something like this. Dot insert. And we need a constant iterator position. Back inserter of all lines, and what we do want to do is the lines, the chunk, so the begin of chunk lines and end of chunk lines. Is that going to work? No, it doesn't. No instance of overloaded function takes, oh gosh, where's number 4? So number 4, iterator pointing to the first element inserted or position if first equals last. Linear distance, input to last plus linear distance between position and the end of the container. Okay, so can I do just end here? Insert at the end. Does that work? Yeah, that works. This is a sad song. Let's replace. We want to be happy here, don't we? You know, at the end of the day, we should have this working, right? Undeclared, identified, all lines. All lines. How is it undeclared? Let job equals n. Okay, in job, but not used. Yeah, we can remove that easily. So job nn, we can remove that easily as well. Okay, now, how fast is this? We have 0 lines. We have 0 lines. So it's very fast. You can see here, they took 0.00 seconds, but it doesn't work because it has 0 lines. And that's one of the things I can tell you guys. I can make anything that you give to me very, very fast. Very, very fast. The fastest you've seen. Faster than, you know, Speedy Gonzalez. As long as it doesn't have to work, right? Anything can be fast. Yeah, so let's select the configure preset. Let's go into Clang debug here and see if we can debug this stuff. So I have all lines, which has been taken as. So I think, you know, it's because this isn't really working, is it? Let's see. So if we find one of those, so size and an end offset must be, yes. So the end offset is wrong here. That's what it should have been. We still have 0 and we have an exception. How beautiful. Yes. let's select the configure preset and let's kind of see what's going on, shall we? And on top of that, because this is multi-threaded, I want to make it a little bit easier to debug by just doing number of cores equals to 1. So we have one worker thread. Okay, that's not nice. So terminated recursively. Okay, that's probably why. I'm running the release thing. Okay, so what we have here. So we've got offset equals, ooh, very big indeed. And size offset. Now, why the hell are they so big? Why are they so big? So it's coming from here. So what is I in this case? Okay, why is it going to 100? Okay, yeah, no, this is definitely not right. It should have just been an number of cores. That kind of makes sense. So the start offset is going to be 0 in this case. That's great. Yeah, we like that. We have 0 lines so far. Wait, why does it say we have 0 lines? Ah, yes. Yeah. It makes sense. It's because it prints it straight away, and that's why. Okay. Now, is there a way for us to wait all of this? Do you drink coffee? Unfortunately, yes. I drink 1 coffee a day. Sometimes even 2. Sometimes I mix in some energy drinks with that as well. It will be the death of me, man. It will be the death of me. But yeah, coffee is just too good for me to give up, so it's one of the things I can't really do. I've been trying to kind of drink less, because I used to drink a lot more. Now I'm kind of down to 1 a day, and that's what keeps me awake, but yeah. So right, yeah, this line is printed before we even finish any of this, by the way, so that's the issue here. So thread pool, can we kind of wait on this? So thread pool, or my pool. Do I have a function to actually wait? No, yeah, that's one of the first things we need to do here. So what do we have to do here? So we have to kind of quit it, right? Let's see what happens when you run. So it pushes the thread handler, and the thread handler receives that as stop. Okay, so if I delete the thread pool, then we should stop all of them, and we push it into the queue, right? We push each one. Okay, so a nice hack that we've got here is to actually delete this, the thread pool, or my pool. What's going on? Expression must be a pointer. Oh no, I can't just remove this. That's fine, I guess, right? We can. I mean, very hackily, I'm gonna just put this onto a stack that will pop the pool out. Okay, so this should I say cause my okay, let's put this up here. Cough gives the mind strength and for the times when, dude, you speak in riddles and I can't understand that, I'm not gonna lie. T on the other hand softens the mind, kills parallel threads so you can focus on coding alone. I do like that though. I do like that. Arconaf, you are kind of like the Riddler dude in Batman. That's how I imagine you in real life. Right, so this should hopefully kind of wait for the thread to finish now. There you go. So we do have that many lines. And how long does it actually take if I do more than one thread, right? So one thread works fine. Now if I do something, where is it, number of cores and chunk size, all of these things can go into here, I guess. So if I do something like 4 cores, right? What do you think will happen, guys? Is it going to be faster? Is it going to be worse? Let's see. So if I first of all select the configure preset, let's go back to release, right? Because release is what we really care about. Unix Ninja release? Unix Ninja release? Yeah, there you go. Let's build it. When you are young, you are already focused, so coffee is better. When you are older, there are too many distractions, so you need the tea more. That's good. I like that advice. I'm gonna take that. What's the issue here though? Okay, so we have different size tea. Not a problem, we can change that to a size T as well. Okay, yeah, it's, as we expect, a lot faster, so it takes 0.22 seconds, and this is a big win, by the way, to read 1,000 lines, right? And as I said, there's something wrong in the code, and I know what's wrong. What's wrong is basically that the chunk size doesn't actually give you the position for the starting of a new line. It will be probably in the middle of a line, so we got to fix that in a second. But right now I'm just seeing the effect of having more cores. So if I do actually how many cores I've got in my machine, so you can see here, which is this many. So where's my CPU? 1, 2, 3, 4. I've got 12 cores overall, but 6 true cores. So if I just do the number of true cores I have, right, and I build it, I expect this to be something like 0.15 to read the entire file. And no, we actually went up, right? I guess didn't really help. Yeah, so it's around that. That's the average. If I do 12 though, which is the number of hypercores I have here, is it going to help at all? That's what I wonder. No, yeah, see, it actually increases the time the more cores I have, because of things like the Linux scheduler, right? So we're running this on the WSL, which potentially has access to all of the cores, but some of these cores have already been used up by the kernel, so it has to like schedule things in and out. So yeah, I think 4 or 3 may be a good stopping point. Let's try 3 and see what we actually get here. So 0.22, again 0.2. So 0.2 seems to be the average, right? But if I do 1, you know, just so you guys, 1, and I recompile this, wait, I don't understand how this is taking. No, this can't be right. What is going on here? This is not changing the time at all. Number of cores. Thread pool equals the number of cores. This can't be right. What is going on here? Why the time's not changing? Where am I? So Unix, well, thread pool app. I'm suspicious now. So why is 1 core giving me the same good result as 4 cores are? This is very suspicious, isn't it? Very, very suspicious indeed. So the executable tests thread pool app. Unix, well. Wait, do I really have to add a thing here to say that we're... So running with 4 workers doesn't really do much. Now, why is that? I don't understand. Oh yes, the art of printf debugging. May I suggest doing 5? I did 5 and it didn't really change. But what I'm really skeptical about is that the first run that we did with 1 core took 0.6 seconds, and now it's consistently taking 0.2 seconds, which is interesting to say the least. Why is that interesting? Because even 1 core is giving me that result. Even 1 core is giving me exactly that. So you have 101 line. Is your memory trained? Some kind of memory optimization by the OS? I would probably guess so, yeah dude, probably that. You've got a good point. So yeah, maybe there are some higher sort of magic happening here, some black magic. It could be caching, it could be like the OS could be caching the results, I don't know. But I think this is still help us in the long run though, because we should have enough to at least do 4 cores here, like 4 cores free all the time, right? And now the next problem that we have to solve is that see, when we run with more than 1 core, we don't necessarily get the other lines that we expect, because some of the lines will be cut in half. In fact, I think the result will become visible when you activate some calculations, at least for the first time you run them. Yeah, indeed. So I'm hoping to see that. But the thing is, there's still a problem here. So this doesn't actually get me a complete line here, because this starting offset. So starting offset probably is not gonna start on a new line, right? So we need to figure out the best new line we can get, and I'm just gonna go back to wherever that new line is though. Yeah, I think this is how we're gonna kind of do. And then we can obviously on the other end say, wait, do we have the file loop here? So say like the first chunk starts like here, right? That's the byte of a first chunk. So what I'm gonna do is I'm gonna go back to wherever the new line is and start there instead. So that's what I'm gonna do there. And on the other end, say like our chunk size, like the last line was here, but our chunk size ends here. What we're gonna do is like, we're gonna say that if the chunk size doesn't end on a new line, we're just gonna ignore whatever line we read from the start to the end, right? I think that's a reasonable enough solution to this, and it should be fast enough. So at least we're not gonna get any overlapping lines, if it makes sense. That's what I'm trying to avoid here. It's nearly 11. I'm having fun with this, but I'm gonna still keep going. Still gonna keep going. Yeah, so let's take a look at this. So we have the starting offset. So I guess we gotta do something like if file.offset is not a new line, so it's not a new line, we're gonna do, you know, find the best place to start the line before the offset. And likewise, and we're going to do the same thing for the end offset. I just realized it can be the same logic. So if the file dot end offset is also not a new line, so we do have a few checks here that we do extra. Right. So this is just gonna be a walk right here, right? So now we can assume that the first chunk is always gonna be a new line. We can assume that for sure, right? Yeah, let's make that assumption. Assumption, when offset that's what we're going to assume here, because if this is not the case, it's going to break the code, and we can add fixes for this later on, but I'm fine with this. So what we're going to do is, like, while the file, the offset, is not a new line, it's not a new line, we're simply going to do offset minus minus, right? That's it. And we're going to do the exact same thing for this. That's it. So this should find a suitable end of offset for both of them. So we have that, and let's build it, and let's see what happens. And this should be fast enough as well. So end the release, and then we have, oh no, this is the wrong one. Now we have 10 million and 4 lines somehow. Yeah, there's something that's not going wrong here. Something that's not going well, I guess. Like what? What's going on here? So I thought this logic should be infallible. This while loop is going to happen on every chunk border line, yes? Yeah, every chunk border lines, but a chunk is big enough though, so it shouldn't happen quite often. And the average line size from what I can see is like 30 characters, 30 to 40. So this should be very fast. You know, every, like, as it currently stands, every 50 megabytes of text, you're going to run this once, which is, I guess, suitable, right? It's not a problem for me. Yeah. So how the heck did we end up with, isn't the outer if statement of the while loop unnecessary? You are quite right, yeah. Thank you, thank you. Let's remove that assumption. Thank you, yeah, that's really good spotting. End offset, end offset. Now, for some reason this gives me 4 more lines than necessary. What I'm going to do is actually something cheeky. I'm going to do a test file and see if we can debug that. See what's happening, right? So I'm going to cat the results out and maybe just put 10 files out. And what we're going to do with this is actually put into weather station small.csv. Okay, and now we can go back into the build. Oh, actually, we can just debug it. Debug Ninja. Do you still have the new lines you echoed to the file? No, I don't. They are gone. I don't save them anymore, basically. I skip the offset when that happens. So let's select debug, so clang debug. Now let's run this, shall we? So we have this, and we have thread pool, weather stations, small. I just want to see what happens right here. Oh, yeah, that was too fast. Why is this not happening? Wait, what? See, we have 12 lines even though there's only 10. This is interesting. Okay, so we just haven't built. My bad. Okay. So these are what my lines look like. First of all, I get one line at the start, even though the file looks like this. Where are we? Where are we? Weather station, small. Right, so this is what we are gonna have. Control V. Wait, how do I split to the left? Split left. No. Split right. Okay. So we have this compared to that. So all lines. So the first one is wait, what the hell? So there's only 10 here, right? Yeah, there's 9. There's actually 9, not even 10. Let's rerun this. BRB gonna switch computer, right? No worries, dude. So all lines, I expect 10 of them. So this happens like twice. Piso firme. Piso firme. Yeah, this is downright broken. This is just nonsense. So what is going on here? It seems to me as if we just kind of... Let me run it again, because I'm not sure. Like, what's the behavior here? Is there anything... Perognov and Lariak. So this happens once, twice, 3 times, 4 times. So I am basically just reading these 2 lines over and over again. Like, why? This is so weird. So weird. So chunk size, start offset plus chunk size. Ah, yes. No, that shouldn't back on the Mac now. Nice, dude. You got a PC and a Mac. That's amazing. Nah, this is not the issue, right? This shouldn't happen. It captures everything by reference. But that reference might be dead after. Is that what's going on here? No, it can't be. It just can't be. So this is where C++ memory management comes to bite us. What happens when you create a lambda that captures everything by reference? So the start and the chunk size seem to always be the same. Let's do that. Maybe this will copy it over here. So that's kind of what I'm doing. Let's see. We have 4 threads and repeating 4 times. Yeah, so we have 4 threads and they're each supposed to kind of run or read a different part of the file. which works a little bit better now. We definitely have a different one. So I guess that this is actually the... This is gonna give me a copyright strike. This is Jojo in here, or whatever. You know, I guess that this one is the one that actually is the 0 offset. Let's take a look at that. Lemsid, no. Yeah, I'm expecting this one to be right. So Volsoroso. I'm just gonna put a breakpoint on this and see what happens here. So let's rerun this and see. Alright, so the offset here in this case is 44, right? I don't know what 44 is, but I bet you it's in here somewhere. So the file offset, it's basically gonna... Oh my god, this is crazy. Yeah, it kind of makes sense why it doesn't work now. It's because I take away from it all the time. So what I have to do is, if it offset is more than or equals to 0, and this wow, that offset is an out of solution space. Indeed, yeah. I guess, you know, this can happen. But I thought the assumption was that these files will always be kind of valid, right? But I guess not. What the hell? What is going on here? Ah, okay, yeah. So we still... Yeah, my bad. Should have been just greater than 0, not greater than or equals to 0. Because if it's equals to 0 and you do a minus, then it's still gonna mess up. So the end offset here is 132, right? So I want to see what happens. Okay, so in this case it kind of looks the same, right? So what if we put this up here? So every function is hitting this now. Ooh. Dude, Vorosovo. What is Vorosovo doing? So it can only be down to 0. Yeah, this can only be 1 here because we can only decrease it to 0 really if we're on the first position there. And then we can do 0. I guess it's the same one for this one here, so... If the offset is more than... that's the thing though. As long as the offset, the end offset, that has to be more than the offset, right? Is the only way here. Why is that? Well, because if end offset is the same as the offset, we can't decrease it. So, right. I still don't think this is going to work. To be honest, I think there's still a larger bug outside that I don't really understand, to be honest. Like, why is this? What does this give me? So the one... So offset and end offset. Offset is 35. And then 73. So where is 35? this is the hex view. So we have 35 and what? In this case, we have 35 and 73. 35 and 73, right? So we have this is 16. Yeah, this is 16. 32. So 35 was right here. And 72. What's 35 in binary? So that's 20. That's 32. 32 plus 3. That's 35. That doesn't make any sense though. So that's my starting one, which means it should look for a different one, right? This is correct. Or am I tripping? So 23. Yeah, it's 35. That's where it starts supposedly, and then we have 73 as the end offset. Which should be 49. Where are we? So 41, 40, 41, 2, 3, 4, 5, 6, 7, 8, 9. So here. Yeah, I don't understand, because this should be going to whatever it is before that. Yeah, so it should be finding like this line here for this one. Huh. I am so confused now. Maybe we made it too complicated. Maybe we've made it too complicated. I'm just gonna push the first one here and see what happens, right? So if we just push the first squall and we debug this, we should be able to see what's going on inside with just one thread, right? So the end offset 35 and the starting offset is 0, so it goes from 0 to 35. Let's rerun this. Copyright. Oh, thank you, dude. Oh yeah, Zelda. No, thank you. So the offset is supposed to be 0 here, and the end offset is supposed to be 44. Okay, so on the first line it works, and the end offset 44. See, we're not on a new line here. How long are we doing this for? So apparently, if the file I offset is 0, I is less than 35, okay. Let's see when we add a line. Lemsid, so I added lemsid here, which is this one. We're fine with that. That makes sense, right? That makes complete sense. What are we trying to accomplish with the end offset? So the end offset should tell my program, you know, where it's going to stop reading, which byte it's going to stop reading at, because I'm dividing the file by the size of the file, I don't necessarily know. It's very difficult to know how many lines you have in a particular window of the file, right? Because, you know, lines differ, and there's no way. It's the lines are random size, basically. So you don't know whether or not your beginning offset or your end offset are going to end up on a new line, because this algorithm works well, or only works when you start precisely at the start of a new line and it ends precisely at the end of a new line, right? That's what we're trying to accomplish here. Find the best offsets for us to start and finish this function so you can read the file. That's what we're trying to accomplish here. Sorry if I wasn't very clear. I understand this is complicated. So all lines now we have limited, and that is it. So why does it only have one? That's my problem here. Well, it only has limited because it's supposed to be, what's the chunk size? So the chunk size here is 44, right? So 44 is the one. So 1, 2, 3. 6, 7, 8, 9, 10, 11, 12, 13. Yeah, so this should have read up to this line, I think, because 44 is in the middle here somewhere. So why did it not read those two lines? That's what I'm expecting the algorithm to do. Maybe I'm too tired here, maybe I need to go to sleep, but I want to fix this before I do. I don't want to derail your current training or thought, but what if we don't care where we are and when to stop? And always count back to the previous end of line while batching. Right, that's kind of what I'm doing though. That's exactly what I'm doing. So unless you start and end at a new line character, as you can see here. So if the current offset here is a new line, we're not going to do this. So if it's not a new line, we just go back to the new line anyway. Does that make sense? And the same for the end offset. I'm trying to keep it simple basically, but by doing that, I've made it complicated. So yeah, and if we do it regardless, then if you do start and end on a new line, or if you just start on a new line and end arbitrarily in a string, you're gonna find the right end offset, but your start offset is gonna go back one line, right? So you're gonna have a duplicated line. That's the problem with that approach, if it makes sense. From what I can think off the top of my head, at least anyway. Oh, I see now what we do is end offset. Yeah. So end offset just says, you know, where to read until. So we read, for example, we start at 0 and we read until the byte 1,000,000, for example, right? So that byte 1,000,000 might or might not be a new line, and we're just trying to find the new line before that. That's all. But of course, it's not working as expected. Let's run this again and see why it's not working as expected. So the end offset is 44. On the first line, it doesn't matter. File at 44. So the data. Oh, there you go. So the data 1, 2, 3, 4, 5, 6, 7. I kind of just want to get the character count. And just think about this in my head for 1 second. So we have that, and we have... Okay, so new lines I'm going to just replace with a star here, because I don't really care. So somehow it will end in here somewhere, right? So 44 actually ends in here. So this is 44 for us. What I'm expecting to do is just to go back until this one here. So it's going to find this one, and this is where it ends. That's all. That's where my end character should be at. So why does it not do that? Oh, please, not an ad. So this character should be a number 36, right? I read lemsip. Oh, it does work. It is a 36. Character 36, or offset 35. So the previous offset is equals to offset. So we are basically reading from 0 to character 36 here, 35. It's not as simple as to change the end offset plus over offset to end plus or equals offset. You might skip a new line now. Not sure, to be honest, stab in the dark. Yeah, it might be helpful. I think it does help if we go line by line now and see what's going on. Because now we know roughly what it kind of should do, like. So for example, it's gonna find, it's definitely gonna read from 0 now, we know that. And it should read at least this line here, right? Which is what we expect. So let's see what happens when we come into this. So that is the first one, right? And our I now is a position for 14, right? So we continue. And then we set that previous offset to be 15 now. So it starts at 15. And then it ends. Ah, no, it doesn't. So as of 15, 16. Is the next offset actually the previous one? 1 second, let me think about that in a second. So basically just trying to go to the end offset, right? So maybe the end offset doesn't actually point to... wait a second. Yeah, I think it's probably just as easy as what Robin said. I think this is causing one subtraction here not to happen, but we'll see that, because currently it's going to go up to 34. That's where my end offset is gonna be at. So 31. So see, this is the last value. So file at 34 is not new line, because the file at 35 is the one. So in the end, we don't actually add the new line. So what it should have been here is that. This is the one. Yeah, because it can't be offset, right? If this is one more than offset, then we're still going to do the minus addition. So we're actually gonna end up at the end offset being 1 minus the new value. God, I hate working with low level. Not low level, but this is not really low level. But raw logic. I just hate that. But now if we build it, and hopefully if we run it, we should get something better, hopefully. I love Kingdom Hearts, but I can't. I have to skip that song, guys, unfortunately. Oh no, it still doesn't work. It still doesn't work. So the end offset, what? I have an idea. So what? So we only stop this for loop when the end offset is at least 1, is at most 1 plus the offset, but also when we find the new line. If we find a new end line, we don't do this. Previous offset equals end offset. Is the next offset cutting the previous one? So, let's see. So previous offset equals end offset. I don't actually know why this is here, to be honest. This is here. Okay, so the previous offset. This is a bad name. This should be something else. This is actually the start of the string, right? This is what it should be called. This just marks where the string starts. So the line starts, basically. That's a better name. So yeah, no, I don't think this is wrong per se. So it's the beginning of the file plus the line start. And then we go up until wherever offset we're at now. And then by doing this, we make sure that the new line start is 1 plus the new line, which means we cut out the new line. I don't think this is wrong. It doesn't look that wrong to me anyway. I think the problem is actually one of these, to be honest with you. So when we find a new line, yeah, when we find a new line, so basically we want to go past that, so end offset plus plus. That's what we want to do, I think. Unfile. Yes. Robin just made it better. Yeah, either that or that. These things are equivalent, I think. So you want to go past the end, right? Thank you, Robin. Yeah, we have 2 lines. Yay, that works better now. So, have we fixed the entire thing though? That's the problem. We fixed one of the issues. Now, there may be more issues, right? So if we do end cause here, I can't even wait to put this through a memory analyzer and see how much shit we're doing here. Okay, yeah, better. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So which ones are we missing here? Yeah, we can figure out which ones are actually wrong. Tonight, Robin, the savior of our logic bugs and eardrums. Yeah, indeed, yeah. Robin has been a good man today. And he's got a maths exam tomorrow as well, man. So he should be really going to bed now. Right, Robin? I don't know what time it is in Sweden, dude, but all I know is that it's probably an hour ahead of the UK, right? You are on the right in the world. Oh no, you're right above. I don't know, actually. So you should be going to bed, dude. So what are we missing? This song is nice, but it's really quiet. So we have Lemsid and we have that. Now we have some random freaking new line here. And then Kritiken. We're missing. We got that one now. For whatever. I'm gonna move this so you guys can see as well. So we have these 2, we have the next 2, and we have the next 2. Piso Firme and Roquefort. And we have Pere, whatever, and Lariac. We just don't have the last one. So I guess this is the first. So the second one is missing, right? We're not we're not missing. We're entertaining a new line every 2 lines. Yeah, we are missing some as well though. We're missing the last line, so we're missing those. But I figured that when we have this, so in other words, the second thread is failing. So the second offset, we're gonna figure out why. We're gonna figure out why right now. Because the second thread, we had 2 lines in here, right, at the start. So we're expecting these, exactly these 2 things here. So the offset, in my case, was initially 44, going up to 88, right? So let's see what we end up getting in the end. So in the end, we end up getting 35, which is what we expect, right? Right? I think it's the same logic in here too, you know. Isn't it because at the end offsets are in the middle of a city, and then because of it gets stripped both left and right, making that disappear? No, I think it's because of the same logic here, dude. We're kind of yeah, we're kind of just, you know, going one offset too much, and we're actually getting the new line baked into the strings. So let's see it now. So we should actually get exactly 2 values here, hopefully, or 3, I don't know. Okay, that's better, right? So yeah, you fix lives on. You fix lives on, Robin. Thank you very much. But I don't think it's fixed the whole thing though. I think that we still have an issue somewhere. Let's see. See, now we're still missing the last one. I can see it should be 10 values. So, as any good programmer, let's see what is going on in the last one. In other words, thread number 3, where it's less than 4, right? I'm going to build this again. Because what we really expect here is to find, I think it was all these values here, right? So that's what we're looking for. Yeah, I think anyway. This song is beautiful. See, because this is the line that we have. What's the size of our file? I don't know. Oh. Right. File. File size is 178. So we should be going to 178 here. No, we're going to 176. So, problem number 1, I know exactly what this is. It's because we have issues with the chunk size. So the chunk size should have been an exact number here. So what do? It's just integer division issues here. I'm just thinking of the best way to resolve this, because I think it would be wise for us to do a rounding here, right? Because we have the size, which is an integer number, and the number of cores, which is an integer number, but this is not nicely divisible by that, right? That's the problem here. So what is the best thing we can do? We can see, the thing is, if I round it up, then the last one is going to have to kind of be the chunk size plus whatever leftovers we have, right? That's the thing here. Yeah, let's do it the hacky way. Because we can't evenly divide it into chunks. Modulo 4 and then add up until it's equals 0. Yeah, so I'm thinking of something like that, yeah, along those lines. So the last one would have to include all the bytes that are missing, modulo 4. Then it's divisible by 4. So in other words, we do all of these the same, but I mean, if statements are very easy, very, very quick. I'm not too bothered about it. What I'm going to do is I'm going to shadow that chunk size. So I'm going to say if I is equals to ncos minus 1. So if it's the last one, what we're going to do is like we're going to do a chunk size. Ooh, right. We're going to shadow that variable for now. It's very bad, but okay. So what we're going to do is this, and if it's the last one, what we do, we do the chunk size. I guess plus the whatever is not divisible by a, right? So mmap dot size modulo 4, as you said, modulo ncos. Otherwise, ncos is what we have. Oh, otherwise it's chunk size. Can I not use this auto const? A variable declared with an auto specifier cannot. Not a problem. Right, I think that's the only place we use chunk sizes. Let's see if this works now. Yay! No, it doesn't work. Why does it not work? Wait, this is even easier, right? This chunk size is even easier, because the thing about it is the last one. So it should be whatever. Start offset. What I'm trying to do here is the following. So start offset plus the chunk size should be equals to map dot size, right? Which means that the chunk size is the map minus offset. All right, yeah, this chunk size. Right. What's chunk lines? Expected a comma. Yeah, I bet you did. Okay. Yeah, this is even simpler than whatever I was doing. We just want to make sure that we get the leftovers, that's all. And it still it still doesn't work. Why? So I'm basically sure that 178 the file is 178. So what's the issue here? Ah, okay, yeah, we're going one past with invalid memory access actually. File offset 178, 177 is that. So the end offset is 178. File 178 is okay. Okay, 178. But we just realized, we just saw that it should be a new line, right? Ah, yeah, this is not gonna work. Okay, another assumption. We always end on a new line. That is the assumption here. We should always end on a new line for the file. Only then it's gonna work, right? So we should make sure that the file ends on a new line. So that's the sanitization of this algorithm. I need to make sure file always ends on new line. Could you not do something like this? Const auto size. Probably could. I am gonna like simplify this shit because this is just like code. This is like not nice to read. I understand that, but we're getting some of the core parts of the algorithm though. Like we get the chunking right at least. So now the thing is, can we do this? Does it still work for the big file? Does it? Does it work for the big file? We will see. We shall see. So I'm gonna go to build, I'm gonna go to Unix, route debug. So we still have 3 more lines. 3 more lines? Then we should have. Does it end with a new line? Good question. I think it does. This one does, yeah. We made sure at the start. Open anyway. Yeah, my computer's working very, very hard to open this file. It ends with 2 new lines, believe it or not. So really, we should be deleting that. So we end on a new line there. Now why is this one not got any data on it? So small, okay. Yeah, I mean my file still ends on a big line there. How can I delete that line? Because Jesus Christ, this is not gonna work on Visual Studio Code. Does Vim open it? If Vim opens it, like it's gray. Okay, so it's writing the file. Vim is so fast, what the hell? It can write the whole file very quickly. Now let's try the build again. So by the way, what are we looking for? We need to do a word count here. So this is the number of lines that we expect here. So this minus 1, I think. So we expect 10 million lines, right? If we don't have any of that, then that means we're simply... we have 25 million lines. Wait, what? No, that can't be right. Ah yeah, we only have 1. Never mind. Oh gosh, I'm getting tired, guys. I'm getting tired. We're gonna do this today. Okay. Yes. We got it. We got it. I'm pretty sure there's still one line too many, and I would love to see which one is too many. Because I kind of feel like it might be the first one. Tokyo, Tokyo, being read twice. Can we debug console this? So all lines. So that is there. That is also there. And that is there. So I don't understand. Simply don't understand how we end up with one more line than we should. What do we do here? So we should end up with this many lines, right? So how does it start? Yeah, it starts at 1. So really we should have size equals 10 million. That's what I'm expecting. I don't know which one is actually messing up on. So we got Tokyo and Tokyo there. Try removing the end line now. So that won't work, I guarantee you, because the algorithm assumes that the end one is always a new line. It's just gonna make us like miss one of the lines at the end, like miss the one here. So instead of getting all these 3 values, we're gonna get just these 2 at the end. That's what we're getting before. It's not that. I think there is something overlapping here. Right? Unless I'm... So we add all of that. It's nearly right though. The algorithm is nearly right. Nearly right. Size. Oh gosh. I mean, I don't think there's much I can do for today. I'm gonna have to go to bed because it's getting quite late. But how fast do we have it now though? That's the problem. That we're trying to fix, right? So if we do thread pool, cd build, Unix rel, see the Unix release ninja. No. Can't even think anymore. So 0.21 seconds, which is cool, I guess. I mean, it's still the same as what we had before, and somehow we ended up with what, even more. What? Why is it? This is not ideal. Can you see this? We're getting 4 more than 3 more. This is not good, guys, I'll tell you that. These values should not be changing. I mean, it's always the same here. Wait, in fact, what are we building for? Ah, we're building for debug. That's why. Okay, that made me scared for a second because I thought we were having some intermittent issues. Okay, so it's consistently one more than we should have, right? Consistently. And out of interest, these all make sense, right? These all make very good sense. We're not getting some weird values here. Okay, yeah. I mean, fairly happy if that's how long it takes, I mean, to load something. So say we take the upper bound, which is around 0.3 seconds, right? So 0.3 seconds to load 10 million lines. So how many is a billion divided by 10 million? So it should take 100 times. Oh my god, yeah, this is quite bad, never mind. So 0.3 times 100. If we're reading a billion lines of code, it takes 30 seconds, which is not ideal, right? We can agree on that. I've told myself today that if we can get anything that loads the file within 10 seconds or less than 10 seconds, I'll be quite happy. This is not that. I'm not happy with this. This is 30 seconds on average to read the entire file. You know, this is running on WSL, which, you know, file access is a little bit slower than usual. So on Windows, maybe this is like half the time, which is 15 seconds. But still doesn't look great, does it? This is very impressive because the guys on this challenge managed to do the whole thing in seconds. Like, how? There's minutes, seconds, and milliseconds. Like, how the hell? This is crazy. Certificate. Thomas Guan. 1 billion row of 2024 in 1 second. Congrats. Even in Java, yeah, it's in Java as well. Like, what are they actually doing? Should we take a peek? I didn't actually take a look at it. Concurrency, atomic, long. So the solution starts a worker process for the actual work. That's actual work such that cleanup of the memory mapping while. So they are using memory mapping, which is what I did. The worker then memory maps the input file. Yeah, we have that. The worker thread. Wait. Creates a worker thread per available core. So far, this is the exact same approach that we're taking here. Then processes the segments of segment size at a time. The segments are split into 3 parts, and cursors for each of those parts are processing segments simultaneously. Like, guys, this is the same thing that we're doing here so far. Results are accumulated into link result objects in a tree map that is used to sequentially accumulate. Runs in 0.13 seconds on an Intel i9, while the reference implementation takes 120 seconds. Wait, what? I don't understand. So they've got branchless programming. So they don't use branches for suggesting memory mapping with unsafe and the subprocess idea. That's kind of what we're doing here, I guess. This for showing the benefits of work stealing at 2 megabyte segments instead of equal split between workers. Hello, Antonio. Oh, dudes. Unfortunately, I'm about to call the stream, but thank you for joining, guys. So I can, yeah, I Jaromir Hamala for showing that avoiding the branch misprediction between less than 8 and 16 cases is a big win, even if more work is performed. So they're using like massive like caching things for the CPU and branchless programming, which is pretty cool. I didn't even know that you can do that in Java, to be honest. But this is their implementation, and I mean, in terms of readability, ours is probably going in the same way, to be honest. Calculate average. Minimum temperature, maximum temperature. So they have a minimum maximum temperature length is 100 maximum cities. They assume that we have 10,000 cities here. Segment size. They make a lot of assumptions from the looks of it. Oh. I'm gonna have to take a look at this because it sounds like a very interesting solution. And they're doing bit masks and everything like that. That's really cool. I don't know what they're doing. I guess they're using something to convert. I would love to learn a little bit about the branchless checks that they're doing here. You can see they have very few if statements, so. But yeah, that's really cool. Like 1 billion lines in less than 2 seconds is impressive. Let's not kid ourselves. And plus they're in Java as well. We just loaded the file, and if we were to parse every line in the dumbest possible way we can think of, which is what we did today, it would take something like 30 seconds, right? Just to load the file. So yeah, kudos to these guys. This is really interesting. I wonder how bad they get though. Like what's the worst one? Bonus results. What the hell? 32 cores, 64 threads. I mean, yeah. If we have like a thread ripper or something like that, then the more threads we have, the better. This action list results from running the fastest n entries with different configurations. $10K key sets. The challenge that contains 413 distinct weather stations where the rule allows for 10,000 different station names to occur. I missed the ending. Did we fix all the bugs and is the old Messiah happy? We fixed most of them, dude. I mean, it still kind of gives me one more line, but it's better than before. And I think it's just like a new line that we kind of have somewhere. I can't tell where that overlap line is, but yeah. Augusta, whoa, so no, Augusta, don't kid yourself, dude. This is just reading the lines. This is just reading the file, and it's only 10 million lines anyway. So it's not a billion yet. This would be 100 times worse. So 0.2 is what we're getting here. I think the average is around 0.25, 23. So it would still take 23 seconds. But it's interesting that it takes only one extra line. If we have that bug, we would think it would happen more than once. Yeah. So tomorrow, if I have some time, guys, I'll actually try and stream getting this stuff done. Because, you know, once we have like the file reading, it's kind of easy to do the rest of it, right? Because all you know, the kind of solution that we got, the underlying aspect of the solution, which is to read the file in different chunks. You know, you have one chunk per core, and the main file is memory mapped into the RAM. That seems to be the same thing that the guy here on the first place had. So I'm kind of confident that's going to work. So tomorrow we just have to kind of just split each line and find the city, and then translate it to the temperature. That's it. I mean, it's not too difficult. So, you know, I think the actual hardest bit of the problem is doing the threading stuff and making it read the exact chunks of the file. So yeah. Thanks for the stream. No worries, dude. Thank you for joining. Arkanaf, guys, it seemed like it was, I mean, cooperation. Yeah. So tomorrow, if you guys are still free, we can try and like actually finish this and see how long it will take for a naive implementation, right? Before we start doing all of the branchless optimizations and SIMD stuff, I think it would be interesting to see what a dumb implementation would actually look like in C++. But saying that, thank you all very much for joining, and it's been a blast talking to you guys. It's been a blast debugging. So yeah, I'm expecting to see you guys again in the future. And once again, bye-bye. Thank you very much. Good night. Like the video, but though, like the video before you go. Like the video. And yeah, that's it. Bye-bye. I'll actually go now.